Hello people, I'm back at it again with another unit review, this time laws of exponents and scientific notation. I am going to try to make this as short as possible, so we're going to get right into it with number one. Number one says the length of a rectangular birthday cake is 4 to the power of 4 and the width is 4 to the power of 9. What is the area of this rectangle? So quickly, so we can talk about exponents. We use 3 words to talk about what we call a power. So a power is what this is all together. An expression such as x to the power of a, which consists of 2 parts, okay? So here, this is a power. The base and the exponent. So if you remember, we talked in class that the base is the big number, the number that we're multiplying by itself. So here they are the same number, 4 and 4, but this big 4 is our base and this small 4 is our exponent. Okay, so look back down here. We are trying to find area. Area is found by multiplying the length and the width of a shape. So if we have a rectangle here, I'm going to draw that out quickly. And the length is 4 to the power of 4. The width is 4 to the power of 9. Well, all I need to do is multiply my length times my width. So 4 to the power of 4 times 4 to the power of 9. This is where our first law of exponents comes in, which is the product of power rules. So the product of power rules says that when I multiply 2 powers with the same base, meaning the same big number, we can add the exponents. So over here, since my 2 powers have the same base, which is 4, that means to multiply them, all I need to do is add the exponents, 4 and 9. So there are 2 steps. The first step is to drop the base. The base is what they share, that's the big 4. And then add my exponents. 4 plus 9 is 13. So the area of the rectangular birthday cake is 4 to the power of 13. Uh-oh. Flip it back around. Here we go. So, number 2 says simplify q to the power of 3, q to the power of 7, j. So, the first thing I think is what's going on here. These are all side by side. That means multiply. So, exactly what we did in the last problem, except I cannot combine all 3 of these because they do not all have the same base, okay? The 2 that I can combine are q to the power of 3 and q to the power of 7, but j is not the same base, so I cannot combine or cannot multiply that with the other 2. So I'll multiply my q's first by first dropping my base, q, and then adding the exponents together. 3 plus 7 is 10. And since we did not touch the j, we just drop it down. Drop that jump. So the final answer is q to the power of 10 times j. Next one, number 3. I have parentheses, lots of junk on the inside, and a exponent on the outside. So when I see an exponent on the outside of parentheses, this is called a power rule, okay? So let's get reminded real quick. To simplify the power of a product, we find the power of each factor, okay? In easier words, that just means we find the power of 4 of everything on the inside, okay? So this 3, this x, and this y to the power of 5, all of them are going to be brought to the power of 4. So this is how this is going to happen. The first step is that everything on the inside needs an exponent. everything needs an exponent. So y already has an exponent, that has 5. But 3 and x do not have exponents, okay? When there is no exponent here, it is an invisible 1. 3 to the power of invisible 1 and x to the power of invisible 1. The second step is we are going to distribute this 4. I like to use the word distribute because we have a number on the outside of parentheses. But instead of distributing to the big numbers, when I have an exponent on the outside of parentheses, I distribute to the small numbers. So 4 is what we are multiplying all of these exponents by. I'm going to write it out like this, times 4 times 4 times 4. Okay, so now from left to right, I have 3 to the power of 1 times 4 is 4. X to the power of 1 times 4 is 4. And y to the power of 5 times 4 is 20. Cool. The last step that I want us to remember is that they may not have 3 to the power of 4 in my answer choices, okay? It may have that number in standard form, which means if I typed into my calculator 3, 3, yx button, 4, okay, my base, and then the exponent button, 4, equals, we could also think to ourselves, 3 times 3 times 3 times 3 is 81. Okay, so 81, x to the power of 4, bring it on down, y to the power of 20, bring it on down. That's our final answer, is 81, x4, y20. All right, cool. Next, I got 4a. So 4a, we have our next exponent rule, which is the quotient rule. Do they not have it here? Here it is, the quotient rule. Okay, so the quotient rule says that when I am dividing, that's what a fraction means, is dividing 2 powers with the same base. So again, these have the same base, a and a. We can subtract the exponents. The way I told us we could remember this in class is by thinking of that fraction bar as a big minus sign. So let's see it happen down here. The first step is to take care of these coefficients. The first step is to take care of these coefficients, so the 6 and the 3. So I want us to think, well, what would we do if we just had a normal fraction like this? Well, we would just divide these numbers like normal, right? That's exactly what happens here. So 6 divided by 3, just like normal, is 2. Okay? The x's is where I do my exponent rule because I have x to the power of 6 and x to the power of, since there's nothing there, it is a 1. Okay, so first step, just like with multiplying, I'm going to drop my base, so we will drop down our x, okay? And then I have 6 minus, that's my big fraction bar, 1. 6 minus 1 is 5. So that's what we have right here. That is true. Moving on, 4b. All right, I'm going to write this one off to the side, so this needs to get out of my way so that we have a little bit more room. 3x over 8 all to the power of 2. Okay, so this is just like number 3, where first everything on the inside needs an exponent. So the 3 has an invisible 1, the x has an invisible 1, and the 8 has an invisible 1. Step 2, I am going to distribute my exponent on the outside, so multiply all of my exponents on the inside by 2. And I'm going to do the ones on top first, so I have 3, drop the base, to the power of 1 times 2 is 2. X, drop the base, to the power of 1 times 2 is 2. And 8. to the power of 1 times 2 is 2. All right, the last step I can do to simplify this, because we see over here, this doesn't look just like it. This does not have exponents for our numeric bases, meaning our bases that are numbers. So I would put in my calculator 3yx button 2, or think to myself 3 multiplied by itself 2 times is 9, okay? X squared is a variable, so I'll just bring it over. And then I have 8 to the power of 2 on the bottom. So 8 multiplied by itself 2 times, 8 times 8 is 64. That's what we have over here. So this second one is true. For C, all right, I got 5x to the power of 9 over x to the power of 4. So first step, I have a big number, we call it coefficient, on the outside. There's nothing on the bottom, so we can think to ourselves, well, there's always a number to the next, there's always a number next to my x. That is an invisible one, okay? So let's divide our coefficients first. 5 divided by 1 is 5. And now we will divide our x's by looking at their exponents, okay, 9 and 4. Back it up, I will drop my base, which is x, and then subtract 9 minus 4 is 5. So 4C, true again. All right, last one, 4D. So right off the bat, I want to distribute my exponent on the outside first. So I'm going to go ahead and put a 1 up here. I'm going to multiply all of my exponents on the inside by 2 times 2 times 2 times 2. And now we are going to work on the top first. So on the top, I have my x. I will drop the base. 4 times 2 is 8. On the bottom, I have 4 to the power of 1 times 2 is 2. And then I have x to the power of -2 times 2 is -4, okay? Some of us have the F word in our heads already. Give me just 1 second, and we will take care of it, okay? First, I want to take care of this 4 to the power of 2, all right? So 4 to the power of 2 means 4 multiplied by itself 2 times is going to be 8. And then let's carry over our x to the power of 8 and our x to the power of -4. Now, what everybody's been waiting for. What the flip, okay? When I have a negative exponent, we need to flip it. It's already in a fraction, which is awesome, meaning right now it's at the bottom, so I'm going to flip it to the top of my fraction, and the exponent turns from a -4 to a +4. Awesome. We just need to remember that when I have a negative exponent, not everything flips, okay? Only my bases with negative exponents will flip. So the x on the top, this guy right here, not going to flip. That's a +8, so it's going to stay on the top. And the 8 on the bottom, okay, is going to stay on the bottom. The last step I could do to simplify here, oh my gosh. I can't believe it. I've made a mistake. If you said this in your head, you're awesome. You're Miss Majorana, still wicked up. 4 to the power of 2 is 16. Duh. Oh my goodness gracious. Okay, so 16. Now the last step is going to be to multiply our x's at the top. So I am going to drop my base, which is x, and then add my exponents. 4 plus 8 is going to be 12. So I have x to the power of 12 over 16, which is not equal to x to the power of 8 over 8. So this one is false. All right, cool. Number 5. I am distributing my exponent on the outside to all of the exponents on the inside, which means everything on the inside needs an exponent. So The 6 gets an invisible 1. The 12 gets an invisible 1. And the y gets an invisible 1. All right, let's distribute by multiplying all of these by the 3 on the outside. Times 3, times 3, times 3, times 3. All right, on the top, drop my base, which is 6, to the power of 1 times 3 is 3. Drop my y to the power of 7 times 3 is 21. Drop my 12 to the power of 1 times 3 is 3. And then drop my y to the power of 1 times 3 is 3. The two things we can do to simplify here are first put these guys in our calculators. So 6 times 6 times 6 is going to be, Alexa, what's 6 times 6 times 6?
6 times 6 times 6 is 216.
Thank you. To bring over my y to the power of 21 over, Alexa, what is 12 times 12 times 12?
12 times 12 times 12 is 1,728.
1,728. And bring over my y to the power of 3. Now, we cannot divide here. 216 divided by 1728 would not give me a, would give me a decimal. So instead, what we could do is use our ABC button to simplify the fraction. So the ABC button, we would type in 216, my ABC button, and then 1728 would simplify that to the fraction 1 over 8. All right. So now that I have my numbers simplified, I can take care of my y's. And the way we do that is just by dropping our base. Okay, so our base is y. It drops to the top because it's going to be a positive exponent. And then 21 minus 3 is 18. So I get 1 times y to the power of 18 divided by 8. All right. One other thing to think about is that this 1 on the outside is not necessary. So we could just think of this as y to the power of 18 over 8, because that 1 is kind of like our invisible ones where they don't really need to be there. All right, number 6. This one is similar to ones we've been solving, except for the fact that 8 divided by 3 is a nasty decimal, but we also cannot simplify, okay? If you typed into your calculator 8 ABC3, it would give you a mixed number, okay? It would give you 2/3. We do not want this, okay? So for a problem like this, where we get a nasty decimal or a mixed number, we just want to keep the 8 on the top and the 3 on the bottom, all right? And then for my A's, I'm going to drop my base, which is A, and subtract my exponents. 9 minus 4 is 5. All right, that is the simplest answer we can get for number 6. Next up is number 7. This is distributive property, real distributive property this time, because I have my number on the outside that I'm going to multiply by my numbers on the inside. So first up is 4r times 8r. Okay, and then we are adding that to 4r times 6. All right, first up, 4r times 8r. So there are coefficients here on the outside, 4 and 8. And if we thought about, if we just had this, 4 times 8, well, we know what to do. We just multiply. We do the same thing here. These coefficients multiply together. So 4 times 8 is 32. Next, my r's, okay? I have r to the power of 1 times r to the power of 1. If we're multiplying two things with the same base, we'll drop the base and then add the exponents. 1 plus 1 is 2. The second one is easier because there is only one variable, so I will multiply my coefficients. 4 times 6 is 24. And then the r is all by itself, meaning we are not going to touch it, meaning it's junk, meaning we drop it. 24r. All right. And then what do we put in between these things? We put a plus because this 24r is positive and not negative. All right, number 8. This is where I tell y'all, whoever made this worksheet, it was not me because I never make mistakes, right? Where was my mistake? I never make mistakes. Just kidding. But whoever made this worksheet made a big mistake, okay? Our answers are going to be different than any of these answer choices, so we are going to add two more answer choices to the bottom when we solve this, and we will see that in a second. So what's happening here is the expression 20a to the power of 5b minus 40a to the power of 4b to the power of 3 has been factored using the greatest common factor, okay? So when we factor something, factoring is the opposite of distributive property, okay? Because 4r, let me use my laser pointer. 4r is a factor of 32r squared plus 24r that we can take out, all right, of both numbers to leave us with 2 factors on the inside of our parentheses. So let's see what happened. We're doing the opposite of the distributive property. The first thing we need to do is find the greatest common factor. All right, so we start, I'm just gonna write these out here. We start with our coefficients, okay? I think this is the easy part to think about because we have learned about that for a couple years. The greatest common factor of 2 numbers, 20 and 40. What I like to do is take the smaller number, so here it's 20, and think, what numbers can I divide 20 by? I'll list out all of my numbers that I can divide 20 by. So I can divide 20 by 1. 20 divided by 1 is 20, which means I can also divide it by 20. 20 divided by 2, yep, I could divide 20 by 2. 20 divided by 2 is 10. 20 divided by 3, nope, that would give me a decimal in the calculator. Can I do 20 divided by 4? Yes, 20 divided by 4 would give me 5. So here are all of my factors of 20. Since I want to find the greatest common factor, I'm trying to find a factor that works for 20 and 40, a number I can divide both 20 and 40 by. I want to find the greatest one, meaning I'll start with the greatest factor of 20 and ask myself, can I divide 40 by 20? That's a yes. So the greatest common factor of 20 and 40 is 20. Okay? Just like with distributive property, our factor is going to go on the outside. So my 20 is going to go on the outside of my parentheses because we're actually going to be dividing, since dividing is the opposite of the distributive property, multiplying. We're going to be dividing both of these by our greatest common factor. But first, we need to think about our variables. So I have a to the power of 5 over here, a to the power of 4 over here. In class, I taught us that we take the smaller exponent, which here would be a to the power of 4, because if we think about it, how many a's do they have in common? Well, they have 4 a's in common, okay? This one has more, so this one I can only divide by 4 before it becomes negative. So they have 4 a's in common, and then I look to my b's. So on the left, I have b1, and on the right, I have b to the power of 3. How many b's do they have in common? They have 1 b in common. So b to the power of 1 would be part of my greatest common factor. All right, now we are going to divide, which means I'm going to take this and write it underneath both of these so that it is very clear what we're doing. So 20a4 b1, we are going to divide. So starting with 20 divided by 20. 20 divided by 20, anything divided by itself is just 1. Next up, a to the power of 5 divided by a to the power of 4. Well, I'll drop my base, a, and then subtract my exponents. 5 minus 4 is 1. And then b. So I have b, I could drop my base to the power of 1 minus 1. Well, that's 0, and that is where we remember another rule of exponents, okay? Anytime I have a base to the power of 0, that is just equal to 1, okay? You could type it in your calculator. Any number. We could type in 4,000. Exponent button, 0 equals, it always will equal 1, okay? So that's what we have for our first term. On the right side, we are going to divide negative 40, a little ugly, divided by 20. Negative 40 divided by 20 is negative 2. Next, I have a to the power of 4 over a to the power of 4. Just like b to the power of 1 divided by b to the power of 1, these are going to just become 1 because they cancel each other out, right? And then b to the power of 3 over b to the power of 1, drop the base and subtract my exponents. 3 minus 1 is 2. All right, so I want to rewrite this in its simplest form, meaning without all of the junk around it. So I know my greatest common factor out here is good. 20a4 b1. Oh, actually, we don't even need that exponent on the b, okay? That 1 can be invisible, so we'll get rid of it. If we look here, really all that we have is this a, okay? Because we do not need this invisible 1 or this invisible 1 or this invisible 1, so it's really just a, all right? Minus, here I have 2 times 1 times b squared, so negative 2 times 1 is negative 2, and then I'll drop my b squared. All right, this is where I tell you, none of these answer choices look like what we got here, but we need to put our trust in Miss Majorina or the math homework hotline video because this is the correct answer. So if the answer choices were laid out like this, 20a to the power of 4b, my factor on the outside would be one of our options. And then all this junk on the inside, a minus 2b squared. All right, those are our correct answers. All right, saving time by moving on to number 9. Okay, Owen weighed 3 different bugs. What is the weight of all 3 bugs combined? So first up, I am looking at numbers in scientific notation. Okay, these numbers, the Sims-Sen numbers, are all in scientific notation, meaning it's not easy for us to combine them, right? In math, combining is adding, and it would not be fun to type all of these numbers into my calculator. What's also not going to be fun is converting them all to standard notation, but that's what we're going to do so that we can practice with scientific notation because it could be a little bit tricky. So starting with our fly, I want to rewrite this number so that it is in standard form, meaning just normal old decimal without any multiplication. The way I do that is by taking this number on the outside, 3.6, and I'm going to write it out over here. Okay? When we multiply it by a power of 10, that means our decimal point is going to move. So I'm going to kill that decimal point. And this negative 5 is going to tell me that the decimal point is going to move 5 times to the left because it is a negative exponent. So it's going to move 1, 2, 3, 4, 5 jumps to the left. All right. All of our blanks are going to get filled in with zeros, 0, 0, 0. And so that is our number in standard form. We'll write out our numbers in standard form and then we'll add them afterwards, okay? So next I have my spider. My spider is 8.2. So I'm going to write that out over here, 8.2. We are going to kill the hopes and dreams of this decimal point and move them 6 blocks away to the left. So negative 6 tells me to jump 1, 2, 3, 4, 5, 6 to the left. All right, I'm going to fill in all my blanks with a 0, 0, 0, 0, 0. And last but not least, this one just has the number 5, which is awesome because we can think about, well, where is the decimal point on a whole number? Is it before or is it after the 5? Well, I want you to think. Here, this 0.5 is 0.5. Well, that's not equal to the whole number 5. But if I put the decimal point after the 5, 5.0, yes, that is equal to my 5. So with a whole number, the decimal point comes after. All right, so put the decimal point after my 5. Then we kill it, and we move it 4 jumps to the left because it is a negative exponent. So 1, 2, 3, 4. Fill in my jumps with zeros, and here we go. I'm going to erase this jump real quick because rookie move, but Miss Majorana does not have her calculator. So I'm going to write out these numbers, starting with the decimal points, so that I can add them quickly for you. 1, 2, 3, 4, 5, 8, 2, and 0.0005. This is how we did it back in my days before there were calculators. All right, so adding from right to left, I have 2. 6 plus 8 is 14. 1 plus 3 is 4. Bring down my 5. 0, 0, 0, and my decimal point. So we don't need all this junk. Sorry you're writing that down. So all of these weights added together, the fly plus the spider plus the bee, are going to be 0.00054442. But Miss Majorana, what if they don't give me my answer in standard notation? Oh, that's a great question. We can convert it to scientific notation reasonably easy, all right? The first step of turning something into scientific notation is finding out what is this number on the left going to be, all right? I find that number on the left by putting a decimal point after the first non-zero number. So, is this a 0? Yes. Is this a 0? Yes. Is this a 0? Yes. Is this a 0? No. This is where my decimal point goes. So, after I put that decimal point there, I'm going to see, without all of these extra zeros, that is my number that goes before my times 10, 5.442. Okay? Then we always have our times 10. And then we need to find our exponent on the 10. The way we find our exponent is by saying how many jumps from my new decimal point to my old decimal point. So for this one, my new decimal point is going to jump to the left. 1, 2, 3, 4 spaces. So that is a negative 4. All right. Oh, I'm going to take a breather after that one. Goodness gracious. Number 10 is what we're going to do next, which should be pretty simple because that is just our power rule again, and then a what the flip negative exponent. So, first step, I'm going to distribute my 3 on the outside by multiplying both of my exponents by 3. So, with my g, I drop the base to the power of 3 times 3 is 9. And then h, drop the base to the power of negative 6 times 3 is negative 18. Because we need a fraction to flip, if we create a fraction, we are going to put a 1 underneath. And then our h, we say, what the flip? It flips to the bottom and becomes a positive exponent, okay? My g will stay on top, g to the power of 9. And that 1 would stay on the bottom, but we do not need that coefficient of 1, okay? So g to the power of 9, h to the power of 18, that is sufficient. And the next one, number 11, is a little bit tricky, but we're getting to the bottom of these questions. The first thing that needs to happen is this 3 on the outside needs to be distributed to the inside, meaning everything on the inside of the first parenthesis needs an exponent. So 4 to the power of 1, s to the power of 1. They are all going to be multiplied by 3 times 3 times 3 times 3. And now we will bring those answers on down. So I got 4 to the power of 1 times 3 is 3. S, drop the base, to the power of 1 times 3 is 3. And then R, drop the base. 3 times 3 is 9. All of that is going to be multiplied by 3. 3S4 R3. All right, we got this. The first thing I want us to think of is multiplying our coefficients, or our numbers. 4 to the power of 3 times 3. Well, to make it a little bit simpler, in my calculator, I could type in 4yx button 3. 4yx button 3, or just 4 times 4 times 4, which would be 64. That's what we're going to multiply by 3. So 64 times 3 is going to be 192. Next up, my s's. So I have s to the power of 3 times s to the power of 4. I will drop the base and then add the exponents. 3 plus 4 is 7. And then my r's. I have r to the power of 9, r to the power of 3. So I will drop the base and add the exponents. 9 plus 3 is 12. All right, number 12. We have this number 0.0096, and we want to write it in scientific notation. So this is what we did before. The first thing I need for scientific notation is the number to go on the left side, which I find by putting a decimal point after the first non-zero number. So I have 0, 0, 0, not 0. The decimal point goes after the 9. And then I fill in this blank with what I see, 9.6. Then we just need to ask ourselves, how many times do we move this decimal point to get back to the old decimal point? So we go 1, 2, 3 jumps to the left. Since we're going to the left, that is a -3. Here's our answers. That was a little bit of a speed run. So take a break. And go to number 13. All right, this says, which of the following numbers are written in scientific notation? So this is where we remind ourselves that there are 2 rules with scientific notation, okay? So we have a number times 10, and then we have an exponent, but there are 2 rules for these blanks, okay? This blank on the left has got to be a number in between 1 and 10, okay? So that's why we always put our decimal point after the first non-zero number, because I always just want one number here so that it stays in between 1 and 10, all right? The other rule is that this exponent has to be a whole number, okay? They call it an integer. I think it's easier to think about whole number, okay? Just we cannot have a decimal or a fraction up here. All right, so let's look at our answer choices. A, we look at our number on the left and we say, is it in between 1 and 10? No, it is not. So A, you're out of here. B, we look on the left side and we say, is this between 1 and 10? 2.36 is between 1 and 10. So I'll look at my exponent. Is that a whole number? Yes, that is a whole number. So B is good. For C, I ask, is this number between 1 and 10? Yes. And is my exponent a whole number? Yes. C is good. D, is this in between 1 and 10? 54 is not in between 1 and 10. So D, you're out of here. And then we have E. Is 3.4 in between 1 and 10? Yes. But is my exponent a whole number? No. We do not want a decimal 3.3 as our exponent. So E, you're out of here too. That leaves us with just B and C. All right, we got 2 more people. Number 14. This is a division problem. I'm going to start with my coefficients on the outside. 15 divided by 5. That one's pretty easy. 15 divided by 5 is 3. Next up are my t's. So I have t to the power of 9 on the bottom, t to the power of invisible 1. I will drop my base, and that fraction bar, that big minus sign, will remind me I'm going to do 9 minus 1 is 8. And then last but not least, I got my u's. So u, we will drop the base and then subtract my exponent. Negative 3 minus 6 is going to be negative 9. All right. I know what's going in our heads. We are saying, what the flip, Miss Majorana? Exactly. We are going to need to flip this negative exponent to make it positive, okay? If we imagine this as a fraction, they are all on top right now, which means when we flip, u to the power of positive 9 will be on the bottom, all right? 3 did not have a negative exponent. It stays on top. T did not have a negative exponent. It stays on top. All right, last question, people. We got Ovilio lives 1.06 times 10 to the power of 6 feet away from his grandma. There are 5.3 times 10 to the power of 3 feet in a mile. How many miles are in between Ovilio's home and his grandmother's? So, whenever I have problems with big numbers in my life, I love to change them to smaller numbers so that I can figure out what's going on in this problem. So I'm going to cross this out and think about a number that's easier for me to think about. I'm just going to think about 100. Let's say he lives 100 feet away from his grandma, right? And then I know there's lots of feet in a mile, but for now, let's just say there's 10 feet in a mile, all right? So let's think about this question again. Ovilio lives 100 feet away from his grandma, and there are 10 feet in a mile. How many miles are there? I want to find out how many miles are in 100 feet. If there are, sorry. I want to know, here, let me write it up. If there are 100 feet, I want to know how much is that in miles? When I know that 10 feet are inside of 1 mile, okay? To solve this, we could think baseball bat method. 100 times 1 is 100 divided by 10. This is the key, all right? I figured out that what needs to happen is I need to divide my first number, which I shouldn't have erased it because I'm sure you erased it on your paper, and I hope you didn't do it at pen. If not, you just copy the answer for me. My first number, which is not 100, it is 1.06 times 10 to the power of 6, is going to be divided by my second number, 5.3 times 10 to the power of 3. Okay. So I'm going to move this over here, and you're saying, Miss Majorana, I'm following along with your writing, and you keep moving these around. My bad. I hope you still have room. Because what needs to happen here, these numbers are in scientific notation. I do not like to divide numbers in scientific notation. I like to divide numbers in standard notation. And this is how I get my numbers in standard notation. I take the first number, 1.06. I kill the decimal point and I move it. This time we have positive exponents, so these decimals are moving to the right. So that moves 1, 2, 3, 4, 5, 6 to the right, and I will fill in my blanks with zeros. Okay, then on the bottom, I have 5.3. Once again, we kill the decimal point. This one is moving 3 times to the right. 1, 2, 3. Fill in my blanks. So what we get here is 1,060,000 divided by 5,300. Alexa, what is 1,060,000 divided by 5,300?
1.06 million divided by 5,300 is 200.
200. All right. Super easy. So we can say that there are 200 miles between Ovilio's home and his grandmother's, or if we wanted to make our lives a little bit harder. And the reason we do this is just in case they don't have the answer 200 as an answer choice, but instead it's in scientific notation, is we'll just review one more time. Okay, I could put my decimal point after the first non-zero number, which is just 2 or 2.0. I always write times 10. And then I say, how many times do I have to jump from this new decimal point to the old decimal point, which again is invisible. It's at the end of a whole number. 1, 2 jumps to the end of the number. So a positive 2. All right. I hope this was a good review of laws of exponents and scientific notation. I'm a little tired. Do not talk about this 4 squared equals 16 in class. And I hope you have a great day. Goodbye.